Alright, today's video is about graphing the solutions to inequalities. So we're going to talk about how do we take something like this and graph it on a number line. So first of all, the first thing that I want to talk about is how we read inequalities. So we should always read an inequality that contains a variable from the variable. So if we're reading from the variable x, and I want you to think we have x, and then what is happening with my inequality sign? Is x being eaten, or is x eating something? And my inequality sign is eating x, so that means that this is a greater than symbol. So we could write this out in words as x is greater than 8. So this inequality means that x is greater than 8. Now x can be any number. It's just that x is greater than 8. So the next thing we need to do before we graph it is we should figure out, do we need to use an open dot or a closed dot? So remember, an open dot we use for the less than or the greater than symbol. A closed dot we use for the less than or the greater than or equal to. Both of these are less than or equal to, or greater than or equal to. So I notice that this is just a greater than sign. It does not have the equal to underneath. So what I'm going to use is a open dot. And what I like to do is I draw an open dot right above it, because then when I bring down here, I'll remember to use an open dot. So to graph x is greater than 8, the first thing I need to do is label my number line. So I'm going to put 0 in the middle. Let me fix that a little bit. I'm going to put 0 in the middle. And then I'm just going to go up by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this time I'm going to do the same. Negative 1, 2, 3, 4, negative 5, negative 6, 7, 8, 9, negative 10. And I'm going to go to a positive 8 on my number line, and I'm going to draw an open circle because we're dealing with a greater than symbol. So 6, 7, 8. I'm going to draw an open circle at 8. And then what I'm going to do is I'm going to figure out which direction is my solutions in. If x is greater than 8, what that's saying is that x is any number that is bigger than 8. So I need to figure out, are my numbers that are bigger than 8 to the right or to the left? The easiest way to do that is that we're going to test 2 points. So I'm going to pick 2 points. I'm going to pick a point that's to the left of my 8 and to the right. So I'm going to pick 5 and I'm going to pick 10. So let's pretend that x was 5 and that x was 10. Alright, so if my original inequality was x is greater than 8, let's see if this one works. Is 5 greater than 8? Is 5 greater or bigger than 8? The answer to that is no. 5 is not greater than 8. So this one does not work. Let's try this one. Is 10 greater than 8? Yes, 10 is bigger than 8. This works. That means that I need to graph, my solution is going to be everything to the right of my circle. So I'm going to go ahead and I'm going to draw a line and an arrow to show that my solution is anything to the right. On your graph, it's good if you kind of shade in a little bit darker and make the line a little bit thicker so that you can really see where your line is going, that it's everything to the right of your dot. Now the second question asks us, is x equals 3 a solution? So let's see. Let's see if x equals 3 works. Well, my original inequality was x is greater than 8. And for this to be a solution, it has to be true. So let's see if when we substitute in x, it is true. If 3 is greater than 8, is 3 greater than 8? Well, if I think about a number line, here's 0, here's 8, here's 3. Is 3 greater than 8? The answer to that is no. So this is not a solution. Not a solution. Alright, let's go to the next problem. Let's say we have an example like h, and then we have a negative 2. So remember that I need to figure out what is this saying right here? Is this saying less than or equal to, or is this saying greater than or equal to? You should always read from the variable. So reading from the variable, I'm noticing that the variable is eating the other number. That tells me that this is a less than or equal to. So I'm going to say that h is less than or equal to -2. Now remember, our second step is that first thing we should do before we even talk about this is figure out what kind of circle do we want. Do we want an open circle or a closed circle? Remember, open circles we use for less than or greater than. Closed circles we're going to use for less than or equal to or greater than or equal to. So I'm looking at this and I have a less than or equal to sign, so I want to use a closed dot. So I'm going to go ahead and I'm going to draw my number line. I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just going to stop there. -1, 2, 3, 4, -5, 6, 7, 8, 9, -10. I'm going to put my closed dot at -2. So here's 0, here's -1, -2. Here's where my closed dot is. I need to figure out which way I should graph. Is my solution all the numbers to the left, or is my solution all the numbers to the right? So I'm going to pick 2 test points. A number to the left is -5. Let's say if that was h, and a number to the right is 5. Let's see what would happen if that was h. So if my inequality is h is less than or equal to -2, if I replace h with a -5, is -5 less than or equal to 2? Well, if I look at my number line, -5 is less than -2. Remember, the bigger the negative number, the smaller it actually is. So this is true. That works. That's a yes. That's a true statement. What if I had 5 is less than or equal to -2? Well, 5 is actually not less than -2. It's over here. -2 is actually less than 5. So this is false. This one does not work. Since -5 works, that must mean that I need to graph in this direction. So I'm going to draw my arrow to show that any number that is less than -2, so any number to the left of -2 on the number line, is a solution. And I'm going to darken that in so I can really see where my solution is. Alright, let's go ahead and answer this question. Is h equals -2 a solution? Alright, if h was -2, and I have my inequality that's h is less than or equal to -2, if I replace h with -2, what happens? Well, I notice here that I have that -2 is less than or equal to -2. This is the same number here. So now I have to look at my inequality. My inequality is less than or equal to. We have an equal to. What that's saying is that it could be less than, or it could also be the number itself. So since they are both -2 and we have this equal to, this is a yes. It is a solution. Let's do another example. Let's say we had 4.5, an inequality symbol, and then a y. Now remember, we always want to read the inequality from the variable. So this I need to read from the y. It's saying that y is, and the inequality sign is eating the number, so y is less than 4.5. We cannot read this as 4.5 is greater than y. We must read it as y is less than 4.5. For me, it's a little bit easier for me to just flip it around and to rewrite it with the y on the left. So I'm going to go ahead and do that now. I'm going to rearrange it and say that y is less than 4.5. Notice that the point of my is at the y up here, and it's also down here, and that this sideways v opens to 4.5 and it opens here. So I just rewrote it so it was a little bit easier to read from left to right, like we would read a book. Okay, so this is saying that y is less than 4.5. We could also make this a little bit fancier. We could say something that like y is, and think back on all the different ways we might see inequalities. We could maybe say that y is fewer than 4.5. It's a little bit of a fancier way of saying it. We can say it a bunch of different ways. So I have it written out in words. Let's figure out what kind of dot we want. I notice that this is a less than symbol. I use this one if it's less than or equal to. I use this if it's just less than. So I'm going to go ahead and put an open dot above this so I can see that it's an open dot. I'm going to go ahead and number my number line, and I'm going to space this out a little bit so we can see. I have a 1, 2, 3, 4, 5, -1, -2, -3, -4. Now, to put 4.5, this is 1, 2, 3, 4, 5. Does 4.5 fall between 3 and 4 or 4 and 5? 4.5 is going to fall in between 4 and 5. It's right in the middle. It's right here. So at 4.5, I'm going to draw my open circle. Now I need to figure out which way I graph. So I'm going to pick 2 test points. I'm going to pick 5 because that's right there. Let's say if y was 5. And then I'm also going to pick 3. It's just on the other side. If my inequality was y is less than 4.5, let's see if that works. If y is 5, is 5 less than 4.5? No, actually 5 is bigger than 4.5. So this is a no. That does not work. Let's try this one. If 3 less than 4.5? Yes, that does work. 3 is less than 4.5. So I'm going to draw my arrow, and I'm going to show that my solution is anything to the left of my dot. Now, it could be these numbers down here too, so you can continue your arrow all the way down. It can fill up the whole graph. It's going to be any of these. Any of these are solutions. If you're going to make it fill up the whole graph, and which we should, we don't need the 2 arrows. We can just put our 1 arrow at the very, very end. All right. Now let's see if we can answer this question. It's asking us, is 4.5 a solution? So if y equals 4.5, is it a solution to our inequality y is less than 4.5? Well, let's see. Is 4.5 less than 4.5? And I'm looking at this and I'm thinking, okay, I don't know if this is true because 4.5, these are the same number, but 4.5 is not less than 4.5. It is 4.5. So because we do not have that equal to as part of this, the answer to this is no. It is not a solution. It is not a solution. Okay, for this next example, I want you to pause, and I want you to try it on your own, and then I will show you how to do it. Okay, so we want to read from our W. So this is saying W is greater than or equal to -10. So W is greater than or equal to -10. Now I have a equal to included in this inequality sign, so I'm going to use a closed dot. I'm going to go ahead and I'm going to write out my points. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -1, 2, 3, 4, 5, 6, 7, 8, 9, -10. I know I need to put a closed dot on -10. I'm going to pick my 2 test points. You might have picked different test points. After -10 here, we're going to have -11, so I'm going to pick -11 as one of my test points. And I will pick, let's say, +10 as one of my test points. So let's see. Is -11 greater than or equal to -10? The answer to that is no. It is not greater than or equal to negative 10. Because negative 11 is smaller than negative 10. Let's try the next one. Is 10 greater than or equal to negative 10? Yes, 10 is bigger than negative 10, which tells me that my inequality is going to be a solution of everything to the right of my dot. So everything to the right of my dot. So I'm going to shade in everything to the right of my dot. Is w equals negative 10 a solution? Well, if w equals negative 10, and my inequality is y is greater than or equal to negative 10, let's see. Negative 10, is that greater than or equal to negative 10? The answer to this is yes, it is. Because we have this equal to, it's okay if negative 10 and negative 10, yes, it is a solution. Alright, let's do a couple more, one more practice. Go ahead and pause the video, try practice example number 5, and then when you're ready, press play, and I will go over the answer. Alright, for this one, we should have seen again that we need to read from the variable. So we can't read it as 6 is greater than or equal or greater than x. We need to read it from the x. So this is actually saying x is less than 6. X is less than 6. I'm going to rewrite this for myself so that it's a little easier to read. X is less than 6. Now, I need to figure out what kind of dot to use, open or close. I don't have an equal to in it, so I'm going to use an open dot. And go ahead and draw out my number line. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 10. X is less than 6, so I'm going to go to the 6. 1, 2, 3, 4, 5, 6. Draw an open dot. I'm going to pick 2 test points to determine which way to go. So I'm going to pick 10, and on the other side I'll pick a 3. So let's see if x is less than 6. So let's see if that works. Is 10 less than 6? The answer to that is no. 10 is not less than 6. Is 3 less than 6? The answer to that is yes. 3 is less than 6. That tells me, since 3 falls on the left, that I need to graph everything to the left of my dot. So I'm going to graph everything to the left of my dot. I'm going to draw my arrow to the left of my dot. Alright, so those are your 2 practice. Now let's go to something that's a little more challenging. Let's take something like this, an inequality from words and graphing. So not only are we going to have to take this inequality that's in words and change it into an equality, then we're going to have to graph it. So it says x is no more than 5. X is no more than 5. Now first of all, we see this is. We see the verb is. That should tell us that it's either going to be an equation or an inequality. Then I see no more than. If you're unsure, I want you to go back to the chart that we talked about the different ways to write it. No more than means that it cannot be more than 5. That tells me that this is a less than or equal to. A less than or equal to. And the reason is, think of it like this. If I said that I can have no more than 30 kids in my classroom, I could have 30, but I cannot have more than that. So I have to have less than that. I have x is less than or equal to 5. It says less than or equal to, so I know that I want to use a solid dot. I'm going to go ahead and draw out my number line. 1, 2, 3, 4, 5. Negative 1, 2, 3, 4. Negative 5, and we'll put up a few more. 6, 7, 8. I'm going to put a closed dot at positive 5. I'm going to pick my 2 test points. So here's my first test point. Number 1, let's pick maybe 7. And number 2, let's pick 3. Well, let's see if it works. Well, is x or 7 less than or equal to 5? The answer to that is no. That does not work. 7 is bigger than 5. Let's try the next one. Is 3 less than or equal to 5? This is a yes. 3 is less than or equal to 5. So I'm going to shade everything to the left of my dot. Let's try B. It has y is more than 5. More than is kind of like a greater than, and I see that I have is in front of it, so I know it's going to be an inequality. So y is more than 5. More than meaning it does not include 5. It's a greater than symbol, so I'm going to use an open dot. I'm going to go ahead and draw out my number line. I'm going to put an open dot at positive 5. And I'm going to pick 2 test points to figure out which way to shade. Let's pick 7. And let's pick 7 and 3 again. So now let's see. If y is greater than 5. So if 7 greater than 5, the answer to that is yes, 7 is greater than 5. Is 3 greater than 5? The answer to that is no, so this one does not work. That tells me that I need to graph the right side. Alright, for these next 2 examples, what I want you to do first is I want you to just try on your own and try to write out the inequality. Pause the video and try to write out the inequality for yourself. Alright, the inequality you should have had for this is z is no less than, meaning it cannot be any smaller than than 7. So we're going to have to say that z is greater than or equal to 7. When you graph that, it's going to look like, here's 7. We're going to have a closed dot at 7. And it's greater than, meaning it has to be bigger than 7, so we should shade to the right. This one, z is fewer than negative 4. Saying z is fewer, meaning it has to be smaller than negative 4. So it needs to be less than negative 4. We need to have an open dot. Draw out my number line. So if it's at less than negative 4, I'm going to put an open dot at negative 4, and it needs to be less than, so it's going to go to the left. Do a couple more practices. I want you to go ahead and I want you to try these 4 on your own. Pause the video, and then when you press play, you can see the answers. Alright, here are the solutions to practice set number 2. So go ahead and take a minute to check your answers. And then if you have any questions, make sure you write them down and come back to class with them. Alright, the last thing we're going to learn on this video is how to write an inequality from a graph. So in your notes, you're going to skip a couple questions, and then we're going to answer how to write an inequality from a graph. So first of all, the first thing we want to notice is what kind of dot we have, okay? So what I do is I notice I have an open dot, so I'm just going to write above this. This is either going to be less than or greater than. So we're going to have to pick it out. The next thing I want to do is I'm going to go ahead and I'm going to just pick a variable, because any of these numbers, it can be any of these numbers. So I'm going to pick a variable like x. X is either going to be less than or greater than negative 5. I just need to figure out what sign needs to go in here. Is it a less than or is it a greater than? So what I would do is pick a test point. So a key point that you should write is pick a test point in a shaded area. So for this first point, I'm going to pick a point like negative 3. And I'm going to think, okay, is x less than negative 3, right? I'm sorry. Just wrote that wrong. Our inequality is going to be, is x less than negative 5? Now let's pick a point like negative 3 and see if that works. Is negative 3 less than negative 5? No, that doesn't work because negative 3 is greater than negative 5. So it can't be the less than symbol. Let's try that same again. Is negative 3 greater than negative 5? Yes, negative 3 is greater than negative 5, so this is going to be x is greater than negative 5. Alright, let's do another example. Let's take this one. I notice it's an open circle, so I know that it's either going to be less than or greater than. So I'm going to say that x is less than or greater than negative 2, and I'm not sure what to put here yet. So I'm going to pick a test point and say, okay, I know that it has to be either less than or greater than negative 2. I'm going to pick a point like 1. Is 1 less than negative 2? The answer to that is no. So it's not the less than symbol. Let's try greater than. Is 1 greater than negative 2? Yes, that works. So it's a greater than symbol. I'm going to do 2 more examples for you. Let's take example number 3. This time, I notice that it's a filled in dot, so it either has to be less than or equal to or greater than or equal to. So my point is at 1, so I know it's either going to be less than or greater than 1. So I have to figure out, okay, x is less than or equal to 1 or greater than or equal to 1. Let's pick a test point. I'm going to pick a point like 4. Is 4 less than or equal to 1? No, 4 is actually greater, so this one doesn't work. Let's try this. Is 4 greater than or equal to 1? Yes, that is true, so I'm going to put greater than or equal to 1. Alright, let's try number 4. Let's try less than or equal to or greater than or equal to. I know it's going to be x is something 5, so let's try this one. Is x, let's pick a point like 6. Is 6 less than or equal to 5? No, that's not true. That does not work. Is 6 greater than or equal to 5? Yes, that works. So greater than or equal to. Go ahead and pause the video and try these last 4 examples, and then press pause, resume when you're ready, and you can see the answers. Here are the answers to the 8 questions. If you have any questions, please write them down. Please make sure you have all your notes and that you come prepared to practice.